Bismillahirrahmanirrahim. Exercise 9.5, question number 5 and 6 are of same kind. Find the values of trigonometric function of the quadrantal angles. The part number 1 is minus pi. Since from the table we have only quadrantal angles in anti-clockwise direction, (0 degree, 90 degree is equal to pi by 2 radian, 180 degree is equal to pi radian, 270 degree is equal to 3 pi by 2 radian. From 0 to 2 pi, or 0 to 3 pi by 2, we have these quadrantal angles first of all, and all angles between them, 0 to 90 degree in first quadrant, 90 degree to 180 degree, 180 degree to 270 degree, and 270 degree to 360 is coterminal to 0 degree. These questions are based on general angle and coterminal angle, concept of general angle and coterminal angle. General angle and coterminal angles. General angle or coterminal angle, the angle which have same vertex and same initial arm and terminal arm. For example, in anti-clockwise direction we have an angle theta. After one revolution, the angle 2 pi plus theta is starting from this line and terminate at this line. Theta is also starting from the line OA and terminate at line OB. So we can say angle theta and 2 pi plus theta are coterminal angles. After second revolution, we have similarly we can say that theta, 2 pi plus theta, 4 pi plus theta, 6 pi plus theta, and so on are all coterminal angles. In general, we can write 2k pi plus theta is coterminal angle of theta. These angles are coterminal of theta. It means the trigonometric functions at coterminal angles have the same value. We remember all trigonometric functions at coterminal angles have the same value. So we can write 2k pi plus theta is equal to theta. These are actually not equal, but in case of trigonometric functions, the value at 2k pi plus theta and the value at theta, any trigonometric function at 2k pi plus theta and theta have the same value. That's why we can write 2k pi plus theta is equal to theta for all k is equal to plus minus 1, plus minus 2, and so on, for all values of theta. Due to this relation, any greatest angle, any greatest or smallest value of the angle can be reduced to small positive theta, where theta is any quadrantal angle from 0 to 2 pi. By using this relation, we can reduce any value of theta, either positive or negative, either greatest or smallest, can be reduced to simple theta, and the value of theta can be taken as 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 180 degree, or 270 degree, whose values we have remembered as minus pi. We have discussed the table of trigonometric functions of different values, where we remember the values of trigonometric function from 0 to 3 pi by 2, or 0 to 270 degree. Minus pi is coterminal to, we can change this, minus 2 pi plus pi. It can be written as 2 into minus 1 pi plus pi. So we have general angle or coterminal angle relation 2k pi plus theta is equal to theta. It means minus pi and pi are coterminal angles. It means all trigonometric functions at minus pi and plus pi have the same value. So we can write sine of minus pi is equal to sine pi 0. Cos of minus pi is equal to cos pi is equal to minus 1. Tan of minus pi is equal to tan of pi is equal to 0. And all the remaining cosec of minus pi is the reciprocal of sine, and the reciprocal of 0 is infinity. Sec of minus pi is the reciprocal of cos, and cos is minus 1. The reciprocal of minus 1 is also minus 1. And cot of minus pi is the reciprocal of tan. Tan of minus pi is 0. Therefore, cot of minus pi reciprocal of 0, 1 over 0, which is equal to infinity. Now we solve second part, minus 3 pi. Minus 3 pi can be written as minus 4 pi plus pi, which is equal to 2 into minus 2 pi plus pi. We have same relation, 2k pi plus theta is equal to theta. It also means minus 3 pi and plus pi are coterminal angles. Minus 3 pi and plus pi are coterminal angles. Therefore, all trigonometric functions at minus 3 pi and plus pi have the same values. So we can write sine of minus 3 pi is equal to sine of pi is equal to 0. Cos of minus 3 pi is equal to cos of pi is equal to minus 1. And tan of minus 3 pi is equal to tan of pi is equal to 0. And the remaining three trigonometric functions are reciprocal of these functions. So we have cosec of minus 3 pi is the reciprocal of 0 in equal to infinity, and sec of minus 3 pi is the reciprocal of minus 1 minus 1. Cot of minus 3 pi is the reciprocal of 0, 1 over 0, infinity. Similarly, we can find the value of trigonometric function at third part, which is 5 pi over 2. It can be written as 4 pi plus pi over 2, because we know that 4 pi plus pi is equal to 5 pi. It can be written as 4 pi over 2 plus pi over 2. So we have 2 pi plus pi over 2. It can be written as 2 into 1 pi plus pi over 2. So we have 2k pi plus theta is equal to theta. 2k pi plus theta is equal to theta. It means the value of all trigonometric functions at 5 pi by 2 and pi by 2 have the same values. So we have sine of 5 pi by 2 is equal to sine pi by 2 is equal to 1. Cos of 5 pi by 2 is equal to cos pi by 2 is equal to 0. And tan of 5 pi by 2 is equal to tan pi by 2 is equal to infinity. And all the remaining are the reciprocal of them. Cosec of 5 pi by 2 is the reciprocal of sine. The value of sine is 1, and the reciprocal of 1 is also 1. Sec of 5 pi by 2 is the reciprocal of cos, and the reciprocal of 0 is infinity. And cot of 5 pi by 2 is the reciprocal of tan, and the reciprocal of infinity is 0. Now we would change only the trigonometric function into coterminal angle, and values can be simplified, simply written in the form of trigonometric functions. The part number 4th is minus 9 pi by 2. It can be written as minus 12 pi plus 3 pi over 2. We can write it as minus 12 pi over 2 plus 3 pi over 2. Minus 6 pi plus 3 pi over 2 2 into minus 3 pi plus 3 pi over 2. So we have 2k pi plus theta is equal to theta. It means all trigonometric functions and at minus 9 pi over 2 and 3 pi over 2 have the same values, and we write all values of trigonometric function at 3 pi over 2. Similarly, we can solve all these questions of this type.